In Lesson 7.2, we're going to work more with the graphs of exponential functions. In Lesson 7.1, we learned how to graph the basic function y equals b to the x. In today's lesson, we're going to move that graph left and right or up and down. As a reminder, just as in the past, when you have a number inside parentheses with the x, so this time that number is going to be the exponent, you're going to move it left and right. When it's a positive number, it moves in the opposite direction. So this one moves to the left. And down here, you still have the number as an exponent with the x, but it's going to move to the right. If you have the number outside, so it's just a regular number, it's not an exponent, it's going to move up if it's positive, or it's going to move down if it's negative. And what I mean by that is the entire graph will move up and down, or the entire graph will move left and right. So let's look at an example. Our first example, graph each function as a transformation of its parent function. The parent function, in this case, is y equals 2 to the x. When I look at the graph, I can see that x plus 1 is an exponent, so I'm going to put parentheses around it. This 1 is an exponent with the x, so that means I'm going to move the opposite direction. It says plus 1, so I'm going to move to the left. The first thing I want to do is go ahead and graph my parent function. To graph it, I'm going to use the same 3 points that we used in Lesson 7.1. My x values are going to be -1, 0, and 1. I'm going to use them to calculate the y of my parent function. So this will be 2 to the negative first, which is 1/2, 2 to the 0, which is 1, and 2 to the first, which is equal to 2. So my parent function will be -1, 1/2. X is 0, y is 1, x is 1, and y is 2. This is not the answer, so I'm just going to dash in this function. This is the basic starting point. Now I'm going to take care of this part that tells me to move to the left. I'm going to move each point left 1 space. So from my -1, 1/2, I move it to the left 1 space. My 0, 1, I move it to the left 1 space. And my 1, 2, which actually should be right here. 1, 2, I'm going to move it to the left 1 space. And now you can fill in the line. They're going to converge down here as y approaches 0. So remember, that's the asymptote. That's the line they won't cross. And then they spread out and become more parallel as you get to the right of the graph. So graph your parent function, and then you'll move each point left or right, up or down. So let's take a look at the next problem. Y equals 2 to the x plus 1. So this time the plus 1 is not with the x value, it's on the outside. So I'm going to do exactly what it says and move each point of my parent function up 1 space. All right, so let's go ahead and graph the parent function. I'm going to push pause and graph it. Okay, I've just plotted the parent function, y equals 2 to the x. Always use the same 3 points, -1, 0, 1. Now I'm going to move each one of those points up 1 unit. So from 1/2, I'll go to 1.5. From 1 up to 2, and 2 up to 3. The asymptote also moves up 1 unit. So it's no longer y equals 0 that it won't cross. Now this is not going to cross at y equals 1. When I draw my graph, it begins kind of parallel to the parent function. And now, as I get further to the right, the two graphs begin to converge. Right, so that's an example of when you move the graph up, and the other one was when you move the graph left or right. All right, go ahead and give this one a try. Use the same 3 values to create your parent function. Go ahead and push pause while you do your work, and then resume play to check your answer. This is the answer that I have. That -2 told me that I'm going to move my parent function down 2 spaces. With my parent function, the -1 made the reciprocal of 1/4, 0, 1, and 1, 1/4. My asymptote also moved down 2 spaces, so I began high, and then as I moved to the right, it approached -2. All right, so that is translating the parent function. Now we're going to look at another type of compounded interest formula. In 7.1, we learned about simple interest. And in this lesson, we're going to learn about continuously compounded interest. With simple interest, that's where your money will sit in the bank for a period of time. And at the end of that time, they calculate how much interest you earn, and then they give that money back into the bank. Continuously compounded is it's just infinitely recalculated and put back into the bank for a certain period of time. The formula that we're going to use, A equals P e to the RT. I want to talk about each one of these variables. A is the total amount that you have in the account after interest has been calculated. P is the principal amount, or the amount that you started with, how much you invested. E is a number similar to pi, where pi is 3.14. E is assumed or rounded to 2.72. It's a button on your calculator. You can use that button, or you can use 2.72. R is your interest rate in decimal form, and T is the time in years. So they're going to give us all the information we need, and we'll just plug it into the formula and calculate. If you have the principal amount of $5,000, so 5,000, an annual interest rate of 6.9%, changing that to decimal would be 0.069, and I have a time of 30 years. So 5,000 times E raised to the 0.069 times 30. Right. Or again, you could use the 2.72. Just make sure that when you raise it to the power, the 0.069 times 30, they're both together in the parentheses. Okay, when I type it into the calculator, I got $39,624.12. Okay, go ahead and try letter B. Try typing it into the calculator. Push pause as you do your work, and then press play when you're ready. This is the answer that I got. If you use 2.72 instead of E, you'll get a slightly different answer, but in the end, it's pretty much the same. $21,557.68. And that concludes lesson 7.2.